Gang, the most basic thing you have to know for your straight line topic is how to draw straight lines, okay? The first type of line we're going to draw are called y equals mx plus c lines. The majority of lines can always be written in the format of y equals mx plus c, about 90% of them. For example, y equals, well, first of all, m and c are numbers. So for example, y equals 3x minus 2. So m is 3, c is minus 2. Or y equals 5x plus 7. M is 5, c is 7. Or y equals x minus 2. M is going to be 1, because x just means 1x. You can add the extra 1. M is 1, c is negative 2. Now, we have to know what m and c stand for. Well, m stands for the gradient of a line, which means the steepness of a line. To find the steepness is the rise over run. So keep that in mind. The m value is the gradient, which means the rise over run. C stands for the y-intercept, where the line crosses the y-axis. So how do we draw these lines? Well, we can use this knowledge of y equals mx plus c. So let's look at this first equation. Y equals 2x minus 5. So step one, we first check, is this line written in the format of y equals mx plus c? Let's have a look. Well, y equals something x minus something. Yeah, y equals mx plus c. So I like to write down what my m value is and my c value is. Well, my m value is the number in front of x, so it's 2. And the c is negative 5. So let's start. I always like to start with my y-intercept. My c value is negative 5. So what that means, my line will cross the y-axis at negative 5. Then my gradient is 2. So what I do is I realize gradient is the rise over run, and that's equal to 2. So my gradient's 2. Now, rise over run is in the form of a fraction. So I have to turn 2 into a fraction. To turn any whole number into a fraction, it's just going to be 2 over 1. So now we can see, for every rise of 2, we run 1. So from this point, we can rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And perfect. We have a nice straight line we've created. And that's your answer. Okay? Sorry, I'll do that in blue because it's in blue. So that's how you draw your lines, okay? So be careful though. Not all lines are written in the y equals mx plus c format, but these lines are. Let's look at the next one. Y equals 2/3 x plus 2. So is this line written in y equals mx plus c format? Y equals something x plus something. Yep, perfect. So our m value is 2/3, and our c value is 2. So we know our y-intercept is 2, and we know our rise over run is 2 over 3. So we have a rise of 2 and a run of 3. So from this point, I'm going to rise 2 and run 3. Rise 2, run 3. And this will be our line, guys. Next one. Y equals negative 4x. Well, this line's pretty much written in y equals mx plus c format because it's y equals negative 4x. So we have our m value, but there's no y-intercept. So let's make some notes. So that gradient is negative 4, but there's no y-intercept. So if there's no y-intercept, we assume the y-intercept is 0. So our line crosses the y-axis at 0, and our gradient is minus 4. So the rise over run is minus 4. So let's turn it into a fraction. Simple, negative 4 over 1. So a rise of negative 4 means a drop of 4. So 1, 2, 3, 4, and run 1. So remember, when we run, we go to the right. So 1, 2, 3, 4, we run once. We got some points. Now we can draw our line. Last one, guys. Y equals 2 plus x. Well, let's see if this line is in y equals mx plus c format. Well, y equals 2 plus x. So this time, they've kind of swapped it. They've put the gradient in the back and the y-intercept in the front. So our gradient, remember the gradient, guys, is always the number in front of x. So x is by itself. X just means 1x. So the gradient is 1. And the y-intercept, remember the y-intercept is always the number by itself. So it's the y-intercept is 2. So we know our y-intercept is 2. So it's going to start here. And our gradient is 1. So rise over run is equal to 1. Let's make this a fraction over 1. So rise of 1, run of 1. Rise of 1, run of 1. Rise of 1, run of 1. And this will be our line. Let me know what you guys think of the y equals mx plus c method, okay? So basically, in a line, most lines usually start with y, and there's a number in front of x with another number at the end. So a number in front of x is always the gradient. The number by itself is always the y-intercept. So gradient, y-intercept, gradient, y-intercept, gradient, no y-intercept, so that means the y-intercept is 0. And the last one, the gradient is at the end because it's 1x, and the y-intercept is 2. Let me know if you have any questions of that one, guys. And here you can try some of these questions all by yourself. You can also, another way you can solve these problems is by drawing a table out. So let's say I wanted to draw y equals 2x minus 5. Here's on the next page. So ym equals mx plus c using a table. So let's say I want to draw y equals 2x plus 5. Let's draw our axis. What you can do is draw a little table instead. Second method number 2, basically, x and y. Whenever you want to draw a straight line, all you require is 2 points. So what you do is you choose any value for x. So let's say x is 0. And we're going to plug 0 into our equation. So it's going to be y is equal to 2 times x. Well, x will be 0. 2 times 0 plus 5. So y will equal to 2 times 0 is 0, plus 5 is 5. So that's our first coordinate, 0, 5. And then you can choose another value for x. Let's say x can be 1. So we're going to replace x with 1. So y equals 2 times 1 plus 5. Y equals 2 times 1 is 2, plus 5 is 7. So 1, 7. So 1, 7 over here. And this is the line. So the table method's good, or you can also use our gradient y-intercept method. So feel free to choose which method works best for you. Awesome. In the last section, we were looking at how to draw lines which are in y equals mx plus c format. But the problem is sometimes not all straight lines will be presented in this format. Take, for example, x plus y equals 5. Is this line in y equals mx plus c format? No, because in the y equals mx plus c format, y has to be by itself. Now it's being added by x. So how do we draw these lines? Well, one option is you can rearrange the equation to turn it into a y equals mx plus c line. So our goal is to get y by itself. So what we can do is we can subtract x from both sides, minus x. So now we have y equals negative x positive 5. And now our line is in a perfect y equals mx plus c format, where our m value, the gradient, is x means 1, so negative 1. And the y-intercept is positive 5. So we can draw our line. So that's one way you can draw these kinds of lines, is by just rearranging it into y equals mx plus c format by getting y by itself. Another way is you can simply just draw a table. And this is how I like to do it, because you don't have to rearrange. When you rearrange, it leads to mistakes sometimes. X plus y equals 5. Guys, just remember, x and y are the x-coordinate and the y-coordinate. So if you want to interpret this, all this is saying is the x-coordinate plus the y-coordinate must add up to 5. So let's draw a table, x and y, and let's just choose a value for x. X can be anything. I like to choose x is 0. So if x is 0, it's going to be 0 plus something is 5. Well, y has to be 5, because 0 plus 5 makes 5. So that's our first coordinate, 0, 5. And I'll mark that in purple. So our first coordinate is 0, 1, 2, 3, 4, 5. 5. Now let's choose a second value for x. Let's say x is 1. So we're going to replace x with 1. So 1 plus something is 5. Well, y has to be 4, because the x-coordinate plus the y-coordinate must add up to 5. So that's our second coordinate, 1, 4. And now we have two coordinates. We can just simply draw our line. Something like that. Next one is this line in y equals mx plus c format. Well, no. We want y to be by itself. Now it's being multiplied by 3, then added by 2x. Ah, crap. How do we do this? Well, don't panic. Just draw our table again. So let's draw a table down here. X, y. So let's just choose a value for x. Let's say x is 0. So let's write our equation. 2x plus 3y equals 6. I'm going to replace x with 0. So 2 times 0 plus 3y equals 6. This one's a little harder. 2 times 0 is 0 plus 3y is 6. 0, just we can just get rid of it. So 3y makes 6. So 3 times something makes 6. Y must be 2. So this is our first coordinate, 0, 2. 0, 2. Let's choose another coordinate. Let's say so same equation, 2x plus 3y is 6. Let's say x this time is 1. So I'm going to replace x with 1. So 2 times 1 plus 3y is 6. Well, 2 times 1 is 2. So 2 plus 3y is 6. And we can solve this problem using a function machine. So we start with y. We always start with our unknown. Well, it's being multiplied by 3, then being added by 2, and 6 is coming out. So we can go backwards. 6 minus 2 divided by 3. 6 minus 2 is 4. 4 divided by 3 is just 4 over 3. And that's our second coordinate. The issue is I don't really want this ugly fractional coordinate. So let's choose another coordinate instead of 1. So let's start from the beginning. Let's say x will be, I don't know, let's say x is 2. So 2x plus 3y equals 6. I'll replace x with 2, so 2 times 2 plus 3y equals 6. So 2 times 2 is 4, so 4 plus 3y equals 6. Let's draw our function machine. So y is being multiplied by 3, then being added by 4 to make 6. Let's work backwards. 6 minus 4 divided by 3. So 6 minus 4 is 2. 2 divided by 3 is just 2/3. Whatever, guys. Let's just leave it at that. 2/3. So that's our second coordinate. 2 and 2/3. So 2, 2/3. We like this. All right? And those are our two coordinates. Let's draw a line. It's not going to be perfect. It's going to look something like this. Let's do our final equation. Is this line in y equals mx plus c format? No, because the y is not by itself. So you can rearrange it, or let's do a table. So the y-coordinate plus 5 must make the x-coordinate. Pretty straightforward. So x and y. Let's choose a value for the x-coordinate. Let's say x is 0. So we're going to replace x with 0. So y plus 5 equals 0. So something plus 5 makes 0. Well, y must be negative 5. Negative 5 plus 5 makes 0. You can also use your function machine. Y is being added by 5 to make 0. Let's go backwards. 0 minus 5 is y. 0 minus 5 is negative 5. So y is negative 5. Let's choose another value for choose another value for x. X can be 2. So y plus 5, replace x with 2. Something plus 5 is 2. Let's use our function machine. So y plus 5 makes 2. So we have to go backwards. 2 minus 5 is y. 2 minus 5 is negative 3. And this is going to be our second coordinate. So let's draw that. So 0, negative 5 is here. And 2, negative 3 is over here. And we can just draw our line. And that's how we draw lines which are not in y equals mx plus c format. So whenever y is not by itself, like x plus y is 5, or 2x plus 3y is 6, let's draw a table. Choose a value for x. So I said x is 0, so I wrote 0 plus y is 5. Something plus 0 plus something is 5, y must be 5. And then I chose the second coordinate, x will be 1, so I'll replace x with 1. So 1 plus y is 5. 1 plus something is 5, y must be 4. And that's how we got our two coordinates. And you just label them and you're all done. So here, let me copy down some questions that you can practice on, guys. Here. Why don't you do these? So on a piece of paper, you can draw x plus y equals 10. Y minus 3 equals x. And 3x plus 3y equals 9. Cool. Give it a shot, guys. Thank you so much for your hard work. The next most important thing you have to know when in this topic is how to find the equation of lines. So basically the reverse of what we were doing earlier, where you were given the equation, you have to draw the line. Now you're given the line, you have to find the equation. So the way to do this is, if we think back to that previous page, we realize that all straight lines can be written in the format of y equals mx plus c. Okay, where c is the y-intercept and m is the gradient. So all you need to do in these problems is to find the gradient of the line and find the y-intercept of the line, and you'll get your answer. Let's have a look at this example here. So step 1 is I like to start by finding the y-intercept, basically finding the c value. So y-intercept is where the line crosses the y-axis. Well, the line crosses the y-axis here. So we know our c value is 4. Next, we're going to find the gradient. The gradient is the steepness of a line. To find the steepness, it's the rise over run. What we do here is we choose any 2 points on our line. I'm going to choose this point here, and we'll choose this point here. Make sure you choose points which are nice and neat and are in perfect coordinates. You don't want to choose this point here because it's in the middle of 0 and 1, and it's in the middle of 5 and 6. That's not very easy. So I've chosen this point here and this point here. And all we need to do is find the rise and the run. So all you do is you draw a little right angle triangle between these points, like that. And what's the rise? Well, the rise is the height. And it's 1, I'll choose another color. And it's 1, 2, 3. The rise is 3, and the run is from here to here, which is 1 box. So the rise over run, the rise is 3. We divide it by the run, which is 1, and 3 divided by 1 is 3. And that is going to be our gradient. So basically our line is y is equal to m is the gradient is 3, so 3x plus c. C is the y-intercept, which is 4, so positive 4. And that's the equation of this line, y equals 3x positive 4. Let's do the next one. It's the same thing, it's a diagonal line. All diagonal lines can be written in the format of y equals mx plus 3. We'll start with the y-intercept. Well, it's here. It's 5, so c is 5. Then we're going to find our gradient. So we choose 2 nice points. I'll choose this point here, and I'll choose this point here. We'll draw our triangle. The rise is 2. The run is 1. So rise over run. is equal to 2 divided by 1. 2 divided by 1 is 2. And therefore our gradient will be 2. So the equation of the line is y equals m. M is the gradient, so m is 2. X plus c. C is the y-intercept. It's 5, positive 5. And that's the equation of this line. Let's go to the next one. Here. Same thing. C, our y-intercept is -1. And our gradient, I'm going to choose 2 nice points. Let's choose this point here, and we'll choose this point here. We'll make a triangle. The rise is 1, 2, 3, 4, 5, 6. The rise is 6. The run is 1, 2. So rise over run, 6 divided by 2 is 3. And therefore, our equation is y equals, m is the gradient, so 3x. The y-intercept is -1. Last one, guys. It's a diagonal line, so it can also be written in the format of y equals mx plus c. We'll start with the y-intercept. Well, it's at 6, so we know our c value is 6. And now we got to find our gradient, our m value. So we choose 2 nice points. I'll choose this point and that point. We'll draw a triangle. Well, the rise is 3, the run is 3. So 3 rise over run, which is 3 over 3, which is equal to 1. Now be careful. This line has a negative gradient. It's going from left to right downwards. Therefore, our gradient will be -1. So our final equation is y equals -1x, and our y-intercept is +6. So here's that tip again, guys. Be careful of the negative and positive gradients. When lines go like this, the gradient is positive. When lines go like this, the gradient is negative. Okay? So this line goes from up to down, going right. Therefore, the gradient will be negative. So on the next page, you feel free to pause the video. You can try and do these questions over here. Cool, man. Give it a shot. Thanks. Finding the gradient between 2 points without a graph. So let's look at this first problem. Find the gradient of the straight line that crosses the coordinate 1, 3 and 4, 9. So unfortunately for us here, we've not actually drawn a graph and labeled the coordinates. So one way we could solve this problem is actually just draw a sketch of this problem. So we have a straight line which crosses 1, 3. So let's label 1, 3. 1, 3. So that coordinate's here. And 4, 9. 4, 9. Here. And it's a straight line that goes between it. Just a really easy, simple sketch, right? It doesn't have to be perfect. And to find the gradient is just remember the steepness. And to find the steepness, it's the rise over run. So what we're going to do is we're going to draw a right angled triangle between those points. So maybe like this. So the rise is this length here. To find this length, it's basically we're starting from 3 and we're going all the way up to 9. So the rise must be 6. And the run is from 1 to 4. So it must be 3. So rise is 6. The run is 3. 6 divided by 3 is 2. And that's our answer. So one way we can solve this problem is by drawing a little sketch really quickly. Another way is we use a formula. The formula goes like this. To find the rise, it's y2 minus y1. It's basically the y coordinate of the second coordinate minus the y coordinate of the first coordinate divided by the second x coordinate minus the first x coordinate. So in order to use this formula, we're going to label both coordinates, coordinate 1 and coordinate 2. All right. And now we're going to get the second y coordinate, 9, minus it from the first y coordinate, 3, over the second x coordinate, 4, minus the first x coordinate, 1. 9 minus 3 is 6, over 4 minus 1 is 3. Yeah, and we have the same rise and run as our sketch. And 6 divided by 3 is 2. And that's your answer. Next one. A is the point with coordinates 1, 4. B is the point with coordinates 7, 22. Find the gradient of AB. Well, basically, guys, AB is the line in between A and B. So same as the previous question. We draw a sketch out. We have coordinate A, which is 1, 4. Let's say it's here, and B is 7, 22, which is above here. So we can do our sketch method first. 1, 4, if you like. So this is good for visual learners. And then 7, 22 is here. And we have to find the gradient of AB, so the line between A and B. So same as before, we can draw our rise and run. So our rise is from 4 up to 22, which gives us a rise of 18. And our run goes from 1 to 7, which gives us a run of 6. So 18 over 6, rise over run is 3. Or we can use our formula. We can call this coordinate coordinate 1, and this coordinate coordinate 2. So gradient is the steepness. So it's the rise over run. So we use the formula y2 minus y1 over x2 minus x1. So the second y coordinate is 22 minus the first y coordinate, 4, over the second x coordinate, 7, minus the first x coordinate, 1. 22 minus 4 is 18. 7 minus 1 is 6. 18 over 6 is simply just 3. And that's your answer. Final problem. The line passing through 4a and 8, 1 has a gradient of 3/4. Work out the value of a. So now, guys, we have two coordinates. We know one of the coordinates fully. We don't know the other coordinate. Well, we know the x coordinate, but we don't know the y coordinate. But I see we have the gradient. So as soon as I see I have the gradient, I just straight away copy out my formula. Y2 minus y1 over x2 minus x1. And I know that gives us a gradient of 3/4. So let's just go ahead and fill this equation out, because right now I have no idea what to do, but I'm going to plug in some values and eventually we'll get the answer. So let's call this coordinate number 1 and coordinate number 2. So y2, the second y coordinate is 1, minus y1, the first y coordinate is a, over x2, the second x coordinate is 8, minus x1, the first x coordinate is 4. And that's equal to 3/4. Then 1 minus a, we'll put this on the side, will stay as 1 minus a. 8 minus 4 is 2. Oh, 8 minus 4 is 4, sorry. Equal to 3/4. Oh, so now our denominators are matching. So our numerators must be matching. If this is 3, this whole thing must make 3. So 1 minus something is 3. Well, if you think back to your negative numbers, so let me write down the equation. 1 minus something is 3. A must be negative 2, because 1 minus negative 2, a minus and a minus turns into a plus, so 1 plus 2 is 3. So A equals negative 2. Boom. Geez. The next section is called Finding the Equation of Lines Given 2 Points. This is directly related to the last section where we find the gradient of the line given 2 points. Now we're going to go one step further and find the entire equation. So let's look at this question first. We're given a picture. We know two coordinates. Coordinate A is negative 3 and 2. And coordinate B is 3 and 8. And we want to find the equation of the line. Well, I see this line, I see it's a diagonal line, and we have to remember, all diagonal lines have the same format. Y equals mx plus 3. Plus c, sorry. Where m is the gradient, and c is the y-intercept. And that's all we have to find. We have to find what the gradient is and the y-intercept. Well, let's start with the gradient, because that's what we were doing in the last section. How do we find the gradient given 2 points? Well, gradient means the steepness. To find the steepness, it's the rise over run. And one way to find the rise is y2 minus y1. And to find the run, it's x2 minus x1. So let's use that formula to find the gradient of this line. So there are two coordinates, -3 and 2, and 3 and 8. Let's call the first equation coordinate 1, and the second coordinate 2. Let's fill in the blanks. So the second y coordinate is 8 minus y1, the first y coordinate, which is 2, over x2, which is the second x coordinate, so 3, minus x1, the first x coordinate, -3, so minus -3. 8 minus 2 is 6. 3 minus -3, a minus and a minus turns into a plus, so 3 plus 3 is 6. 6 divided by 6 is 1. Well, we know straight away that the gradient is going to be 1. So y is equal to m is 1, so 1x plus c. Now we have to find the y-intercept. To find the y-intercept is actually pretty straightforward. All you do is you choose one of the coordinates, -3, 2, or 3, 8. Let's say we're going to choose 3, 8. I'll write down my equation. And the coordinate I've chosen, 3, 8. And all you got to do is replace the x with the x coordinate and the y with the y coordinate. So I'll replace y with 8. So 8 is equal to 1 times x, which is the 3, plus c. 8 is equal to 1 times 3 is 3, plus c. So 8 is equal to 3 plus something. Well, c must be 5. So our y-intercept is 5. And therefore, our final equation is going to be y is equal to 1x. C is the y-intercept. Well, c is 5, so it's plus 5. And this is the equation of our line. And yeah, the line, it looks like it has a gradient of 1. It's a positive gradient. And it kind of looks like it's crossing at 5. So we're pretty much correct. Now we can do the same problem without a diagram, okay? So let's look at this first problem. Find the equation of the straight line that passes through these pairs of points. Step 1, I will find the gradient first. So gradient is going to be the same formula, y2 minus y1 over x2 minus x1. So y2 is 1 minus y1 is 5 over x2, which is 4, minus x1, which is 3. 1 minus 5 is -4. 4 minus 3 is 1. -4 divided by 1 is just -4. So that's our gradient. So straight away we know it's going to be y is equal to -4x plus c. We don't know what the y-intercept is. So -4 is the gradient, and therefore I replaced m with -4. Then to find the y-intercept, you choose one of the coordinates. Doesn't really matter. Let's choose the first one, 3, 5, and we're going to plug it into our equation. So the y coordinate is 5, so I'll replace y with 5 is equal to -4 times x. Well, x is 3 plus c. 5 equals -4 times 3 is -12 plus c. -12 plus something is 5. How do I do this? Well, I'll draw a number line. We're at -12. We're trying to get to 5. Well, to get from -12 to 0, we have to add 12. And from 0 to 5 is plus 5. So in total, we have to add 17. So c must be 17. -12 plus 17 must be 5. So c equals 17. And therefore, our final equation is y is equal to our gradient's -4, so -4x plus 17. And this is our final answer. Let's do it for the next question. So find the equation of the straight line that passes through -5, 10, -10, -5, and -7, 4. Step 1, we'll find the gradient using y2 minus y1 over x2 minus x1. So the second y coordinate is 4 minus the first y coordinate is negative 5. So it's 4 minus negative 5 over x2, which is negative 7, minus x1, negative 10. 4 minus minus 5, minus minus turns to a plus. 4 plus 5 is 9. Negative 7 minus minus 10, minus minus turns to a plus. Negative 7 plus 10 is 3. Can we simplify this? Yes, 9 divided by 3 is 3. And therefore, our gradient is going to be 3. So y equals 3x plus c. Now we have to find our y-intercept. So we choose one of the coordinates. I'll choose the first coordinate. And I'll replace the y into here. And the y into here. And the x into here. So y is 4. I'll change color. Equals 3. X is negative 7. Plus c. 4 equals 3 times negative 7 is negative 21 plus c. So negative 21 plus something is 4. Negative 21 to 0 is plus 21. From 0 to 4, it's plus 4. So 21 plus 4 is 25. The y-intercept is 25. And therefore, our final equation is y is equal to, well, our gradient is 3, so 3x plus 25. And this is the equation of the line that cuts through negative 10, negative 5, and negative 7, 4. So step 1, you find your gradient by using y2 minus y1 over x2 minus x1. And then, to find a y-intercept, you choose either coordinate and you plug it into your equation so far, okay? And you'll find c. Now you can try the your turn section. There's 4 problems there, and give it a shot. Thanks. Next part of gradients, guys. And these are some harder gradient problems. Let's give these a read, and I think we'll be all right. So find the gradient of the line passing through the points 4a, negative a, 6a, 5a. What the? How can we have a's as? How can we have variables like a's as coordinates? That's impossible. Well, let's try and work through this problem. Find the gradient of the line passing through these points. Well, we have 2 coordinates, I suppose. And I think to myself, how do I find the gradient? Well, it's the rise over run. And to find the rise over run, you can use a formula. y2 minus y1 over x2 minus x1. So I suppose we can just use our formula. So let's have a look. So our equation is 4a negative a and 6a 5a. This is the first coordinate, this is the second coordinate. And let's plug into our equation. y2, the second y coordinate is 5a minus the first coordinate, y coordinate, negative a minus a, over x2, the second x coordinate, 6a, minus the first x coordinate, x1, 4a. 5a minus minus a minus and a minus turns into a plus. 5a plus a makes 6a. 6a minus 4a makes 2a. 6a divided by 2a, we can cancel out a's on both sides, and 6 divided by 2 is 3, and this is our gradient. In this problem, it's quite easy to get overwhelmed by these a's, but don't. You're asked to find the gradient, just use your formula and trust the process. Just plug each of these coordinates into the y2 minus y1 over x2 minus x1, and you will eventually get the answer. Let's look at a couple more. We're going to do 4 and 6 together, and you can do the rest by yourself. So to practice, you can do question 3, question 5, question 7. So let's do question 4. The line passing through negative 8, negative 9, and negative 2h has a gradient of 4. Find h. All right, so I have one full coordinate. I'm trying to find this other coordinate. And we know the gradient is 4. So we're given the gradient. So I'm going to straight away write down our y2 minus y1 over x2 minus x1. And in this problem, we know this gradient is equal to 4, because it says the gradient is 4. And let's go ahead and fill this out. I'll copy out my coordinates. So y2, the second y coordinate is h. All right, we'll just leave it as that. Minus y1, negative 9, over x2, the second x coordinate, negative 2, minus x1, the first x coordinate, negative 8. And that, we know, is equal to 4, because the gradient's given to us. Now let's simplify it now. So that's step 1 is we make our equation. Step 2 will simplify. H minus minus h, a minus and a minus always turns into a plus. So h minus minus h is basically h plus 9 over negative 2, negative negative 8. A negative and a negative turns into a plus. Negative 2 going forwards 8 is going to be 6. And that's equal to 4. So we've made some sort of equation and now we've simplified it. And now we're going to solve this. So what do we have so far? We have h plus 9 over 6 equals 4. So something plus 9 divided by 6 makes 4. Well, to solve this, we can use our function machine, or we can just think about it logically. Something, this whole thing, divided by 6 equals 4. So the top number in total must make 24, because 24 divided by 6 makes 4. So if the whole top section is 24, something, h must be 15, because 15 plus 9 makes 24, so h is 15. Or you could use your function machine, so I'll show you how we can do that. So we start with h, it's being added by 9, then it's being divided by 6, and then 4 is coming out. And we're going to go backwards. 4, opposite of dividing by 6 is multiplying by 6. Opposite of adding 9 is minusing 9. 4 times 6 is 24. Minus 9 is 25. Oh, minus 9 is 15. So h is 15. So there's two ways you can do it. You can use we call this the chunking method, or you can use the function machine. Let's try question 6. So the line passing through negative 2, 5, and 2n has a gradient of negative half. Find n. Well, we're given two coordinates, and I'm given the gradient. So as soon as I see the word gradient, I know I might have to use this formula. Let's see what's on the next page. So it's negative 2, 5, and 2n. And the gradient is equal to negative half. So I have two coordinates. Let's use our y2 minus y1 over x2 minus x1. So y2 is n, y1 minus y1 is 5, over x2 is 2, minus x1 is negative 2. And we know that gradient is equal to negative half. Next, let's simplify this. Well, n minus 5 just stays as n minus 5. 2 minus minus 2, the minus minus turns into a plus. So that makes it to be 4, and that's equal to negative half. Next, n minus 5 divided by 4 equals negative half. Well, we can use our function machine. Why don't we use our function machine to solve this? So we start with n. It's being subtracted by 5. Then n is being divided by 4. And what's coming out is negative 1/2. So we have to go backwards. Negative 1/2. Opposite of dividing by 4 is timesing by 4. Opposite of subtracting 5 is adding 5. So negative 1/2 times 4. Well, how can we do this? Well, 4, we can write as 4 over 1 times negative 1/2. We can put a negative on top over 2. And then it's just top times top. Negative 4 over bottom times bottom. 1 times 2 is 2. And then negative 4 divided by 2 just makes negative 2. So now we have negative 2. And we have to plus 5. Negative 2 plus 5 is 3. And this would be your answer, n equals 3. So feel free to bang out the rest of these questions, guys. Question 3, 5, and 7. Awesome, thanks. Next concept, which is parallel lines. Parallel lines are lines that are always the same distance apart. For example, these two lines. If I draw these two lines, at any point along the lines, they're exactly the same distance apart. And if I keep drawing these lines, they'll always stay the same distance away from each other. So these lines are parallel. Another example is like this. These lines are parallel. So if I extend the lines, they'll always be the same distance away from each other. Or like this. These lines are parallel. So I keep drawing the lines, I keep extending them. They're the same distance away from each other. These lines are not parallel. So if I keep going on this line, I keep going this line, they're eventually going to touch at this point here. And when we do our linear graphs, there's one really important fact about parallel lines we have to know. To do that, let's use an example to illustrate this. Let's draw our axis. Let's draw a line. Let's say this line is y equals 2x plus 2. So gradient is 2, so the rise over run is 2, and the y-intercept is 2. And let's draw a line parallel to this. So let's change color. So we'll draw another line which will never touch it. So maybe like this. And let's see what we notice about the line. Is the gradient or is the y-intercept the same? Well, for sure, the y-intercept is higher than this y-intercept. This y-intercept looks like about 5. But what do you know about the steepness of the line? The steepness is exactly the same as our original line. So we can call this line y equals 2x, because it's got the same gradient, plus 5. So the fact we have to memorize is that parallel lines always have the same gradient. Really important fact. Parallel lines always have the same gradient. These two lines are parallel, and if you have a look at it, they're both equally as steep. One across, two up. One across, two up. They only just have different y-intercepts. So parallel lines always have the same gradient, which is basically the m value. So let's draw some more parallel lines to this black line. Well, we have a line like this. Okay, so let's find the equation of this line. Well, it looks like the same steepness as the black line, so it's going to be y equals 2x. But now the y-intercept looks like it's minus 6, so minus 6. Or we have this line over here in red. Y equals, well, it's the same steepness as the black line, so the gradient's going to be 2 again. But now it's crossing the y-axis at about -3, minus 3. So all these lines are parallel, and look what you notice, they all have the same gradient. So let's look at these problems. Write down the equation of a line parallel to 2x minus 3. So we have to find a line which is parallel to this line. Well, let's think back to our fact. Parallel lines always have the same gradient. So for sure, we know it's going to be y equals 2x. And then the y-intercept doesn't even matter because we had plus 5, plus 2, minus 3, minus 6. We can put any y-intercept, minus 5. Or we could have y equals 2x plus 100. Or we can have y equals 2x minus 7, as long as the gradient is always the same. So you can have there's like infinity possible answers, okay? There's not just one answer here. As long as the gradient is 2. So let's look at the next question. Find the equation of the line parallel to y equals 3x minus 7 and passing through 4, 15. So we need to find the equation of a line which is parallel to this line. So straight away, we know this missing line will have a gradient of 3. Because parallel lines have the same gradient. So straight away, we know the equation is going to be y equals 3x. And now we have to find the y-intercept, so plus c. To find the y-intercept, all we're going to do is we're going to get this coordinate that this line passes through, 415. And we're going to plug this coordinate into this equation. So I'm going to replace y with the y coordinate, which is 15, equals 3 times x, which is the x coordinate, which is 4. So 3 times 4 plus c. So 15 equals 12 plus c. So 12 plus something is 15. C must be 3. So our final equation is y equals 3x plus 3. Next problem. Write down the equation of the line that is parallel to x plus 2y equals 4 and passes through 0, 5. So I need to find the equation of a line which is parallel to this line. So these two lines must have the same gradient. The problem is this line is not in y equals mx plus c format. So before we can find the gradient, we have to rearrange it first. So we have to put this line in the y equals mx plus c format. It's basically get y by itself. So step 1, in order to get y by itself, let's get rid of this x. So we'll minus x and minus x. So we have the x's cancel out. So it's just 2y equals 4 minus x. We want to get y by itself, so we're going to get rid of that 2. So we're going to divide by 2, we'll divide by 2, we'll divide by 2. So that cancels out. So it's going to be y is equal to 4 divided by 2 is 2. X just means 1x. So 1 divided by 2, we just leave it as half, negative 1 over 2x. And let's rearrange it so the gradient is in front. So we can write it as y equals negative half x positive 2. So this line, x plus 2y equals 4, is exactly the same as y equals negative 1 over 2x plus 2. And so we can see now our gradient is negative 1/2. So therefore, the gradient of this line we're trying to find must also be negative half because the lines are parallel. So straight away we know it's y equals negative 1/2 x plus c. And then to find the c value, we know that this line crosses 0, 5. So we're going to throw these coordinates into this equation. So the y coordinate is 5 equals negative 1 over 2 times x, which is x is the 0, times 0 plus c. So 5 equals negative half times 0. Anything times 0 is 0, so 0 plus c. So 0 plus something is 5. C must be 5. So our final answer is y equals negative half x, and our c value is plus 5. And that's it, guys. So this is the only fact you have to know about parallel lines, that parallel lines always have the same gradient, which is the same m value. So if the m value is 2, if we're trying to find a parallel line, make sure your m value is also 2. Here, the m value is 3. We were trying to find a line parallel to this, so our m value had to be 3. And we have to find a y-intercept, and same for this equation here. Let's go on to the next page. Lines A and B are parallel. The line A passes through 0, 8. Yep, I can see that, passes through 0, 8. Line B has equation y equals 3x plus 1. Write down the equation of line A. Well, we know line A and B are parallel. Therefore, parallel lines, the fact we learned on the last page is parallel lines always have the same gradient. So straight away, we know the equation of line A is y equals 3x2. And we have to find the y-intercept. And we can see this line crosses the y-axis at 8. So our final answer is going to be y equals 3x, and our y-intercept is plus 8. That was an easy one. Let's look at the final problem, and you can get started by yourself. A straight line passes through the points 0, 6, and 4, negative 2. A straight line M passes through the point 0, 1, and is parallel to line L. Find the equation of line M. Okay. One way we can do this problem is just by drawing a sketch. You can actually do a sketch on all these previous problems to help you visualize it. Let's draw a nice quadrant. Line L, it passes through 0, 6, let's see, 0, 6, and 4, negative 2. So line L passes through here. And a line M passes through the point 0, 1, which is here. And we also know this line is parallel to line L. So it's going to look like this. It passes through 0, 1, and it's parallel to line L. And we have to find the equation of this line. Well, if I'm trying to find the equation of line M, so it's going to be y equals, well, I don't know what the gradient is, but I know the y-intercept is plus 1. So we got to find what the gradient is. Well, in order to do this, we should find the gradient of line L first. Once we find the gradient of line L, since they're parallel, line M should have the exact same gradient. So how do we find the gradient of line L? Well, we can use our y2 minus y1 over x2 minus x1 formula, because we have two coordinates for line L. Let's go ahead and plug this in. So y2, the second y coordinate, so negative 2, minus y1, the first y coordinate, 6, over x2, the second x coordinate, minus x1, the first x coordinate, minus 0. Negative 2 minus 6 is negative 8. 4 minus 0 is 8. Negative 8 divided by 4 is negative 2. So I know the gradient of line L is negative 2. And since line M is parallel, the gradient for line M must be negative 2 as well. So our equation is y equals, the gradient's negative 2, so negative 2x. And when I do my picture, it crosses at positive 1. And this is our final answer. Another way we could have got positive 1 is, well, we first find a gradient, well, it's y equals negative 2x. Another way to find the y-intercept, so plus c, is just plug in this coordinate into this equation. So we'll replace y with 1 equals negative 2. Replace x with 0 plus c. 1 equals negative 2 times 0 is 0 plus c. 0 plus something is 1, c is 1. So if you don't draw a diagram, you can do it using this method here. And yeah, c is 1, and this is our final answer. And that's pretty much all we need to know for parallel lines, guys. On the next page, feel free to do these questions over here. So give it a pause, try these questions, and if you have any questions, just let me know, okay? Thanks so much. And just remember, parallel lines always have the same gradient. That's it. Cheers. The next section from parallel lines are perpendicular lines. Perpendicular lines are lines that meet at a right angle. All right. For example, a line here, if I was to draw a line perpendicular, it could be like this, meet at a right angle. Or it could be like this, right angle. Or like this, right angle. Or if I have a line like this, I could draw a line like this, and they meet at a right angle. or like this, it would be like this. They meet at a right angle. These lines are perpendicular to each other. Similar to parallel lines where there's a rule, where the parallel line rule is that lines that are parallel have the same gradient. There's a rule for perpendicular lines, and it's really important you memorize it. Lines that are have negative inverse gradients. Okay? What do I mean by negative inverse gradients? So let's say we have a line. Kind of looks like that. I'm going to say the gradient is, or the m value is 2. If I was to draw a perpendicular line, the gradient would be negative inverse. So a lot of people would say, oh, the gradient's negative 2. That's wrong. First, you're half correct. First, if the gradient for this line is positive, this line must be negative, and it looks like it. So that's the negative part done. Now you have to inverse it. What's the inverse of 2? Well, if we were to write 2 as a fraction, it would be 2 over 1. So all you do is you inverse that. So the opposite of 2 over 1 is 1 over 2. So if a line has a gradient of 2, the perpendicular gradient would be negative half. Let's try another one. Let's say I've drawn a line like this, and the gradient is negative 3. I'm going to draw a line perpendicular, so like this. Okay? To find the perpendicular gradient, to find the gradient of the perpendicular line, well, this line is negative, this is going to be positive. And then the inverse of 3, well, 3 is just 3 over 1, so I'll just do the reverse of that, 1 over 3. So we went from negative to positive, and from 3 over 1 to 1 over 3. Okay, we'll do another example. Let's say I have a line. The gradient is negative 1. Say the gradient's negative 1/4. So the perpendicular line will look something like this. Well, if this line is negative, this line will have a positive gradient. So for sure it's going to be positive. And the opposite of 1 over 4 is going to be 4 over 1, which is just 4. So if one line has a gradient of negative 1/4, the perpendicular line will have a gradient of 4. So negative inverse. So now let's practice some of these questions. Write down the equation of each of the following lines. We need to find a line which is perpendicular to y equals 2x plus 3 and passes through 0, 3. The first thing I'm going to do is, well, if our line is y equals 2x plus 3, and we're trying to find a perpendicular line, well, we know perpendicular lines have negative inverse gradients. So if the gradient of this line is 2, the gradient of our new line should be y equals 2. Well, if it's positive, it's going to be negative first. And 2 is 2 over 1. So we're going to flip it to 1 over 2. X plus c. Well, we don't know what the y-intercept is yet. And in order to find the y-intercept, we can just plug in this coordinate, because our line we're thinking of is perpendicular to y equals 2x plus 3, and it also passes through 0, 3. So I can replace the y and the x with 0, 3. Well, y is 3, x is 0, plus c. 3 equals negative 1/2 times 0 is 0 plus c. 0 plus something is 3. C is 3. So our equation is y equals negative 1 over 2x plus 3. Let's try the next problem. X plus y. So find the equation of the line perpendicular to x plus y equals 6 and passing through 0, 1. So our equation is x plus y equals 6. The problem here is that this line is not in y equals mx plus c format. So before we find the new gradient, we're going to have to rearrange it so y is by itself. Well, I see y is being added by x. So I'm going to subtract x on both sides. So that cancels out. It's going to be y equals negative x plus 6. Negative x just means negative 1x. So we have to find a line perpendicular to this line. Well, if the gradient of this line is negative 1, the perpendicular gradient will be, well, y equals, if it's negative, it's going to come positive, and 1 as a fraction is 1 over 1. Opposite of 1 over 1 is just 1 over 1, which is simply just 1. So the gradient is just going to be 1x plus c. Now we have to find the y-intercept, so we just plug in 0, 1 into our equation. So the y-coordinate is 1 equals 1 times x-coordinate, which is 0, plus c. 1 equals 1 times 0 is 0 plus c. Something plus c, 0 plus something is 1. 0 plus 1 makes 1, so c is 1. So y equals 1x plus 1. Let's do the final one. Ooh, I still made a spelling mistake. Perpendicular. Find the equation of the line perpendicular to y equals 2/3 x plus 4 and passes through negative 6, negative 4. Well, so we have a line. It's perpendicular to this line. Let's copy that down. So I know, since the lines are perpendicular, the gradients must be negative inverse. So if the gradient for our first line is 2/3, if this is positive, it will become negative first of all, because it's negative inverse. And then 2 over 3, the opposite of that is just 3 over 2, x plus c. So I just swap the fraction. And then to find the c value, I can plug in negative 6 and negative 4. So y is going to be negative 4, because negative 4 is the y-coordinate, equals negative 3 over 2 times x, which is negative 6, plus c. So first we have to do negative 3 over 2 times negative 6. Let's write it out here. Negative 3 over 2 times negative 6. I'll turn negative 6 into a fraction. Negative 6 over 1. Top times top. Negative 6 times negative 3 is positive 18. 2 times 1 is 2. 18 divided by 2 is 9. So it's going to be negative 4 equals 9 plus c. So 9 plus something is negative 4. Well, c must be negative 13. 9 plus negative 13 will make negative 4. So c is negative 13. So our final equation is y equals, our new gradient is negative 3 over 2x minus 13. Just one simple fact you have to memorize, guys. Lines that are perpendicular have negative inverse gradients. That's the only fact I've been using so far. Let's look at the next one. Find the equation of the line perpendicular to line I and passing through point A. So basically our line is going to be perpendicular to line 1 and it's passing through point A. Well, before we can find, so it's going to look something like this. They meet at a right angle. So it's just a bit of sketch. So before I can find the black line, which is what my goal is, let's find the equation of line 1. So all lines can be written in the format of y equals mx plus c. Let's find the gradient, which is the rise over run. So I'll choose 2 points along this line, 2 nice points, so this point here and this point here. Yeah, these are 2 nice points. Let's write down the coordinates. So the first coordinate here is 0, negative 2. The second coordinate is, actually no, let's just draw our triangle between them. No, actually, better to use the y2 minus y1 equation over on this one. Yeah, so you can either draw a triangle and find the rise and the run, but here our graph's a little small, so let's just use our equation. So the two coordinates we've chosen are 0, -2, and 2, 0. So y2 is, the second y coordinate is 0 minus y1, which is -2, over x2, which is 2, minus x1, the first x coordinate, which is 0. 0 minus minus 2, a minus and minus turns into a plus, so 2 over 2. The gradient is 1. So we know this line has an equation of y equals 1x, and the c value is the y-intercept. The y-intercept is it's crossing at -2. So our line has to be perpendicular to this. So we know perpendicular lines have negative inverse gradients. Well, if the gradient of the red line was 1, the inverse of 1 is, first of all, if this is positive, it'll become negative. And 1 as a fraction is 1 over 1. And the opposite of 1 over 1 is just 1 over 1. So it's just going to be -1 over 1. 1 divided by 1 is simply just 1. So our gradient is just y equals -1x. And it's crossing the y-axis at +4. And that's our equation of the line, because the gradient is -1, and our line, it's crossing the y-axis at +4. Let's move on to the next page. A straight line passes through the points 1, 4, and 5, 16. We're going to skip part A because it's about parallel lines. You're welcome to try it though. Find the equation of the line perpendicular to AB and passes through the midpoint of AB. So this line we're thinking of, it passes through the middle of AB. So it's going to look like here. And it's perpendicular. So our line is going to look something like this. I like to draw it out just to give me some visualization of what my goal is. All right. So we got to find the equation of this pink line. Well, first of all, if these two lines are parallel, I know the gradients of these lines are negative inverse. So why don't I find the gradient of the red line first by using my y2 minus y1 over x2 minus x1 formula. So for the red line, the coordinates are 5, 16 and 1, 4. And to find the gradient, we'll do y2 minus y1 over x2 minus x1. y2, the second y coordinate is 4 minus y1. This first y coordinate is 16 over x2. The second x coordinate is 1 minus the first x coordinate is 5. 4 minus 16 is -12. 1 minus 5 is -4. -12 divided by -4. A negative divided by a negative is a positive. And 12 divided by 4 is 3. So we know this line has a gradient of 3. And honestly, we don't really care about the y-intercept. We just care about the gradient, because perpendicular lines have negative inverse gradients. So therefore, if the gradient of this line is 3, the gradient of our pink line should be the negative inverse of this. Well, if the gradient is 3, our gradient should be negative, and 3 as a fraction was 3 over 1, so our gradient will be 1 over 3. So far we know that our line has an equation of y equals -1/3 x plus c. So now we have to find the y-intercept, where it crosses the y-axis. Well, we know our line, this pink line, crosses the red line at the midpoint of A and B. So if you think back to the previous sections, we got to find the midpoint of A and B. Because once we find the midpoint, we can plug the y-coordinate of the midpoint and the x-coordinate of the midpoint into our new equation. So to find the midpoint, midpoint of A and B, we use that formula. You add up the x-coordinates, and you divide it by 2, and you add up the y-coordinates, and you divide them by 2. So our coordinates are 1, 4, 5, 16, So x1 plus x2, so let's add the x coordinates. So 1 plus 5 divided by 2 is 3. So we know our x coordinates 3. And let's do the same thing to our y coordinates. y1 plus y2 over 2. 4 plus 16 is 20, divided by 2 is 10. So we know the midpoint of A and B is 310. And now, since we know the pink line crosses through 310, we can plug 310 into our equation. So y is 10 equals negative 1/3 times x is 3 plus 3. Negative 1/3 times 3, we'll do it on the side. 1/3 times 3, well, it's going to be 3 over 1. Negative 1 times 3 is negative 3. So even though it's negative 1/3, I like to put the negative on top. So it looks like this. Over 3. Negative 3 divided by 3 is negative 1. So 10 equals negative 1 plus c. So negative 1 plus something makes 10. Well, c must be 11. So our equation of our line is y equals negative 1/3 x plus 11. A lot of steps, but hopefully that made sense, guys. Oops. Final problem. The point A is 5, negative 2, and the point B is 11, 1. Find the equation of the line perpendicular to AB and passing through the origin. Well, origin just means 0, 0. So basically, we have a line which is perpendicular to the line crossing these 2 points. So if we find out the gradient of line AB, our line we're looking for is perpendicular to this. So we can just do the negative inverse gradient. So let's first find the equation of the line AB. And let's just do a sketch to visualize this. So I like to draw a sketch if I'm super stuck. Point A is 5, negative 2. So 5, negative 2. And point B is 11, 1. So this is called line AB. And we have to find the equation of the line perpendicular to line AB and passing through the origin. So our line we were looking for is definitely passing through this point here. And it's perpendicular. Well, it's going to look something like, it's not accurate, but it's going to look something like this. So we show a bit of a sketch, and they're going to be at a right angle. So we have to find the equation of this green line. So let's first find the gradient of AB. And once we find that, we can do the negative inverse to find the gradient of our green line. So to find the gradient, we'll do our y2 minus y1 over x2 minus x1 of the blue line. So I'll do it in blue. So y2 minus y1 over x2 minus x1. y2 is, the second y coordinate is 1 minus the first y coordinate, which is negative 2, over x2. The second x coordinate is 11 minus the first x coordinate is 5. 1 minus minus 2, well, minus minus turns into a plus, so it's 1 plus 2 is 3. 11 minus 5 is 6. This is just a fraction, 3 over 6. If we simplify it, it's just going to be 1/2. So gradient of the blue line is 1/2. Since we know the green line is perpendicular, we have to find the negative inverse of 1/2. Well, first of all, 1/2 is positive, so we know our gradient of our line will definitely be negative. And the inverse of 1 over 2 is just going to be 2 over 1. And 2 over 1 is just the same as 2. So our gradient of our green line is negative 2. So far we know it's y equals negative 2x. And it says our line passes through the origin. Oh, that's very convenient. Therefore, we know our line has a y-intercept of plus 0. So this is the equation of our line. Awesome, guys. Hope you found that okay. On the next page, feel free to pause and try this section here. Thanks so much. Okay, gang, next section, which is called the midpoint of lines. I think this is actually a fairly straightforward concept. Let's get started. Find the midpoint of these segments. A segment's basically a line. So we have a line from A to B. We have to find the midpoint. This one, it's pretty obvious. We go along. This looks like it's the midpoint. So the midpoint's 3, 3. For this one, it's also fairly obvious. The midpoint looks like it's around here. 3, 4. If you're super stuck doing this problems like these, you can actually use a formula right here. X1 plus X2 over 2, Y1 plus Y2 over 2. Let's say we're trying to find the midpoint of this line, and we're not 100% sure what the midpoint is. What we do is we'll write out both coordinates. So the A coordinate is 1, 5, and the B coordinate is 5, 1. Okay? And what we're going to do is we're just going to plug in this equation. So to find the midpoint of the X coordinate is we add up the X coordinates, so 1 plus 5, and divide it by 2. 1 plus 5 is 6, divided by 2 is 3. So we know the midpoint of the X midpoint is 3, and to find the midpoint of Y, we do the same thing. We're going to add up the Y coordinates, so 5 and 1, and divide it by 2, which is 3. So midpoint's 3, 3. We can do the same thing here for this problem here. If we're super stuck and we're like, yo, where's the midpoint? We'll write down both coordinates. So coordinate A is 2, 2, and coordinate B is 4, 6. So to find the midpoint of the x's, we're going to add up the x coordinates, so 2 and 4, and we're going to half it. So 6 plus 4, 2 plus 4 is 6, divided by 2 is 3. So we know the x coordinate of the midpoint is 3. And then to find the y coordinate of the midpoint, we add up the y coordinates, 2 plus 6, and we divide it by 2. 2 plus 6 is 8, divided by 2 is 4. And the midpoint of the y coordinate is 3, 4. Yep, and that is our answer, 3, 4. This formula comes in handy when you have questions without a diagram. When it's a diagram, it's actually pretty easy to see where the midpoint is, but we like to use this formula when we have a question without a diagram. Let's have a look. Find the midpoint of the line joining these coordinates. So we have a line, and it's joining these two coordinates together. So let's do a quick sketch perhaps. -5, 2, so -5, 2, which is this coordinate here. And then 5, 4, so 5, 4, this coordinate here. And there's a line between it. And we have to find a midpoint. So on a test, you can't just draw out a diagram. It's going to take way too long. So let's just use our formula. So let's add up the x coordinates. So -5 plus 5 and divide it by 2. -5 plus 5 is 0. Divided by 2 is 0. And we'll do the same thing for the y coordinates. 2 plus -4 over 2. A plus and a minus turns into a minus. So it's going to be 2 minus 4, which is -2 over 2. -2 divided by 2 is -1. So the midpoint between these two coordinates is going to be 0, -1. Let's do the second one. So there's a line that connects -3, 9 to 7, -1. And we have to find the midpoint. So we can use our formula again. So to find the midpoint of the x's, we're going to add the x's, x1 plus x2, and divide it by 2. -3 plus 7 is 4, divided by 2 is 2. And we'll do the same thing for the y coordinates. So y1 plus y2 over 2. 9 plus -1, a plus and a minus turns into a minus, so it's just 9 minus 1, which is 8. Divide by 2 is 4. So the midpoint is 2, 4. I'm not going to do the last two because I think it's fairly self-explanatory and not too difficult. Let's go to the next page and let's look at some harder problems. M is the midpoint of QP. Find the coordinates of Q. So coordinate M, is the midpoint of Q and P. Find Q. All right. So this time it looks like we have the midpoint, and we know one side of the midpoint. We got to find the other side of the midpoint. So in a question like this, when it's about a midpoint, I'm going to write out my formula first. So x1 plus x2 over 2, and then y1 plus y2 over 2. And I'm just going to fill it out. So let's say this is the first coordinate, and then q is the second coordinate, which we don't know. So x1, so that's the first x coordinate, which is 9, plus x2, which is the second, right, x and y, which we don't know yet. Second x coordinate, which we actually don't know. So it's going to be 9 plus x divided by 2. And we know the x midpoint is 7.5. So this should equal 7.5. And then we can use our function machine to help us. X is being added by 9, then divided by 2, and 7.5 is coming out. Let's go backwards. 7.5 times 2 is 15, minus 9 is 6. And therefore, the x coordinate of Q must be 6. And let's do the same thing for the y coordinate. So the first y coordinate is 8, plus the second y coordinate, we don't know it, so we'll leave it as y over 2. And we know the midpoint has a y coordinate of 0, so that's equal to 0. And we're just going to solve this. Again, we can use our function machine. Y is being added by 8, divided by 2, and then 0 is coming out. So 0, we times it by 2, and we subtract 8. So 0 times 2 is 0, minus 8 is just negative 8. And therefore, our y coordinate is going to be negative 8. So 6, negative 8. And that's the answer to this question. The coordinate of Q is 6, negative 8. Let's try the next problem. So here, it's the same thing. We have the midpoint, which is M. We have one coordinate. We don't know its other side. So since I have the midpoint, I'm going to use the midpoint formula. x1 plus x2 over 2, and then y1 plus y2 over 2. So let's call this coordinate coordinate 1, and this coordinate coordinate 2. So x1, the first x coordinate is 2, plus the second x coordinate, we don't know yet because we're trying to find q. So let's leave it as just x over 2. And we know the midpoint, the x coordinate is 4.5. And so we can use our function machine to solve this because we've created an equation. So x is being added by 2, then divided by 2, and 4.5 is coming out. So we're going to go backwards. 4.5 times 2 minus 2. 4.5 times 2 is 9, minus 2 is 7. So we know the x coordinate of Q is going to be 7. Now let's do the y coordinate. So we'll do the exact same thing. I'll do another color. The first y coordinate, oh, where's my colors? The first y coordinate is 20, plus the second y coordinate, well, we don't know it yet. It's just still y. We got to find it. Over 2, and we know the midpoint has a y coordinate of 13. This must be 13. And to solve this, to find y, we can use our function machine. So y is being added by 20, divided by 2, and then 13 is coming out. So let's just go backwards. 13 times 2, which is 26, minus 20. 13 times 2 is 26, minus 20 is 6. So y is 6. So coordinate Q is 7, 6. And that's how we do it, guys. We see we're given the midpoint. We know one coordinate. We're trying to find the other coordinate. We just simply use our midpoint equation, plug in the numbers, and solve and find out what the x and y value are, okay? So for some practice, you can give this page a try. So here, find the midpoints. You can either use your formula or just use it by eye. Here, find the midpoints of the line joining these coordinates. Probably best use the formula. And here's those tricky ones where you're given the midpoint. You know one end, and you have to find the other end. So you can use your formula again. Just plug in the right numbers in the right places and work backwards from there. All right, cheers, homies.